For the last few days, we started with vertex form. We went to standard form, found the axis of symmetry. We found the vertex. We found another point. One of the next things that we have to work on is we need to be able to find what are called the zeros to give us additional points in order to graph. In order to find those zeros, we need to do a couple days of factoring review to make sure that you're good with your factoring pieces of it so that we can go on then to that next part. So today we're going to cover two parts of factoring. Well, more than two parts, but we're actually going to cover day 4 and day 5 of factoring. We're going to start out with GCF, grouping and differences of squares, and then we're going to look at factoring trinomials. So remember when you're factoring, what we're trying to do when we're factoring out things or when we're factoring is we're trying to use properties that we are before and kind of go in the reverse order. So 2x times 3x minus 1, that's called factored form. Okay. We distribute that into get 6x squared minus 2x. And we've done the distributive properties. We've FOILed. We've done all of those different types of things. So we've gone this direction. Our goal for today is to go the other direction, to go from 6x squared minus 2x and factor out the greatest common factor so we have something that's equivalent to it. And eventually this is going to allow us to solve different types of equations. So if we look at this first example, we've got the binomial 5x plus 10. Anytime you're factoring, whether there are 2, 3, 4, 17, whatever, terms within that polynomial, the first thing you always have to look for is you have to look for what's called the greatest common factor. So when you're talking about the greatest common factor, you're looking at each of the individual terms and looking at the number that they have in common that you could divide out and the variable that they have in common that you could divide out if there was one. Now when we're talking about factors are always going to be smaller. Multiples are bigger, factors are smaller. So when we're looking at the numbers 5 and 10, what's a common factor for 5 and 10? 5. 5 is a common factor for 5 and 10. So then essentially what we're going to do is we are going to take each of these terms and divide it by 5. The result of what's left then is going to go inside the parentheses. So 5x divided by 5, that just leaves you with x. 10 divided by 5 is just 2. So this is the factored form of 5x plus 10. And eventually we're going to set this equal to 0, and we're going to find zeros and do those different types of things. Today we're just working on the factoring part. So if we look at the second one, 20a to the 5th minus 24a cubed. Again, we have to look for the numbers first. So 24 and 20. 24 and 20. Well, I know 2 goes into it, so I'm going to take a 2 out. I know. Letter-wise, what's another one? A to the how many? A to the 3. Okay, so I'm going to take 2a to the 3 out because I think 2 is my greatest common factor. Or I think 2a cubed is my greatest common factor. If I take 20 and divide it by 2, what do I get? I get 10. A to the 5th divided by a cubed is a squared minus 12. Well, I did something wrong. 10 and 12 have a common factor. 10 and 12 have a common factor of 2. Okay, so I've got 2a cubed. I have to take another 2 out because I messed up. If I take a 2 out of there, I'm left with 5a squared minus 6. So what do I do with this 2 and 2? Multiply them together. So even if you mess up, and you don't take out the GCF. You just take out a common factor, which happens sometimes. Always make sure you look, because sometimes when you take it out, sometimes you just don't know what it is. So find something that works. And then hopefully something else will pop to your mind once you get it to that point. And then make sure you take that out as well. Go ahead and do that one real quick, and we'll call this part of it good. Greatest common factor? 5x. And again, it just means that we're going to divide both of these. Don't write this down. So we get 3x plus 1. We good with taking out GCFs? All right, so that's the first one, GCFs, factoring out using GCFs. Second thing we're going to do is we're going to factor by grouping. I'm not going to use the box method to do these. We're just going to factor by grouping because we're going to do that more often anyway. So we're going to factor by grouping. When you're factoring by grouping, you're doing exactly that. You're going to group things together. Now, we use factoring by grouping anytime you have 4 terms. That's when you're going to look to factor by grouping, and just 4 terms. Step 1, you still have to look to see if there's a GCF. 5, 15, and 3, there's not. 3 doesn't have, negative 3 doesn't have, so we don't have a GCF. So the first thing we're going to do is we're going to group the first 2 terms together. And we're going to factor out a GCF for the first 2 terms. So GCF for the first 2 terms is 5x squared. 5 divided by 5 is 1. X cubed divided by x squared is x. Minus 15 divided by 5 is 3. So I have the first grouping taken care of. Now I'm going to group the second 2 together, and I'm going to take out a GCF. What's the GCF? 1. And we do have to take that out. So we're going to take out a 1. It doesn't change what I have inside of parentheses at all. But now what you notice, if I look at this, now I'm down, I went from 4 terms to really I'm down to 2 terms. That's one of my terms, and this is one of my terms. I went from 4 terms to 2 terms. Now these 2 terms, both in the yellow and in the orange, they have a common factor. The common factor for them is x minus 3. So I'm going to take out that common factor. That common factor is x minus 3. And when I take out that common factor of x minus 3, I'm left with 5x squared. Plus, if I take x minus 3 out of 1 times x minus 3, I'm left with 1. This now is the factored form of our original piece of it. And I can do this because they had a common factor in this second step. If you got to this second step and they didn't have a common factor, you could not do this. They have to have that common factor in this set. If it's not there, you can't do it. Then you just go back to your original and say that's as good as it gets. That's its factored form. Okay? Let's look at a second one. Okay, so let's look at this one. We've got 2x cubed minus 12x squared minus 3x plus 18. Four terms means that I should factor by grouping. I group the first 2 terms together. Common factor is 2x squared. That leaves me with x minus 6. Group the second two terms together. There's a minus symbol in between. What's the common factor for 3x and 18? 3. But notice what I've taken out. Notice essentially this is minus 3. So I need to take both of these and essentially divide them by negative 3, or negative 3, not negative 3x, just negative 3. So negative 3x divided by negative 3 just gives me x, and that one's usually not the problem. But 18 divided by negative 3 is negative 6. And again, with factoring, you can always check to see if you're good. If I distribute it back in, that's 2x squared minus 12x squared minus 3x plus 18. So I've got what I need. And now you'll notice they have the common factor. They have a common factor of x minus 6. So I can take out that common factor of x minus 6. And I'm left with 2x minus 3. That's the factored form of that. That is factoring by grouping.
You forgot to square the x.
Oh. There you go. Thank you. So 2x squared minus 3. All good? Remembering how to do this stuff now? All right, then that leads us to the third one in this part, differences of squares. The one that if you can get this shortcut down, makes your life lots easier. Because we do end up doing a lot of difference of squares stuff in here, and you have to be able to recognize differences of squares. So differences of squares, by definition, it's two perfect squares that are subtracted from each other. Okay, so essentially difference of squares means that I have a squared minus b squared. That's two squares being, perfect squares being subtracted from each other. Now a perfect square is the result of multiplying something by itself. So a times a is a squared. 3 times 3 is 9. 9 is a perfect square. A squared is a perfect square. 25 is a perfect square, and so on and so forth. When you do this, the result of a squared minus b squared, the result is a minus b times a plus b. And as long as they're a difference of squares, this is always going to be the case. Where the a value in the factored form is the square root of a squared. The b value is the square root of b squared. And then it's just going to be a minus b and a plus b. If you put a plus b, a minus b, doesn't matter. It's the same thing. But if you work it backwards, a squared plus ab minus ab, that's why they go away. And then you've got minus b squared. So some examples. X squared minus 9. Always check to see if there's a common factor first. There's not a common factor. X squared is a perfect square. 9 is a perfect square, and they're being subtracted. That means we can write this in factored form as x, square root of x squared is x, square root of 9 is 3, and then x plus 3. That's your solution, and you're done. And if you can recognize it's a difference of squares, it makes life a lot easier. Okay. With that second one, the second one's a little bit deceiving. Because 100's a perfect square and so is 36. And they're being subtracted. However, you can't forget the first piece of factoring. Take out a GCF. 100 and negative 36 have a GCF. So you have to take that GCF out first. Common factor for them is 4. So that leaves us 25b squared minus 9. Now, if you look at what's inside parentheses, 25 is a perfect square, b squared is a perfect square. They're being subtracted, and 9 is a perfect square. So this has to be taken a step further. The 4 comes along. Square root of 25 is 5. Square root of b squared is b. Square root of 9 is 3. And then you have to put 5b plus 3. So that's your solution for that one. So be careful. Sometimes it can get a little bit tricky. Make sure you take a GCF out first. Some things that are not examples and why. 8's not a perfect square. Simple enough. It has a plus sign. Anytime it has a plus sign, it's not a difference of squares. Difference means to subtract. X cubed isn't a perfect square, so it's not a difference of squares. X isn't a perfect square, so it's not a difference of squares. Questions with their differences of squares? Do number 8. Go. Factor that. Square root of 16. So 4x minus 5, 4x plus 5. So we've worked on 3 things so far that we should be good with. GCF, grouping, and factoring by differences of squares. Any questions with those? All right, the next part then that we're going to work on is we're going to work on factoring trinomials. So everything we've had kind of up till now has been a binomial, been 2 terms or 4 terms. So what do we do if we have 3 terms? 3 terms, just like if it has 2 terms or if it has 4 terms or if it has 710 terms. First step is to take out any GCF. If I have 3x squared minus 15x plus 18, what's the common factor? 3. So I'm going to take out a 3. If I take 3x squared, if I take a 3 out of that, that gives me x squared minus 5x plus 6. Okay, so now, the goal now, we've got this trinomial here. The goal with the trinomial now is to break this up into 2 binomials, if we can. So the 3 is always going to come along, and we're going to try to break this up into 2 binomials. Now, if we start thinking through the process, we know the first 2 terms, in this case, are pretty easy. They have to multiply together to be x squared. Well, that has to be x times x. You've got no choice there. It's x times x. We also know that the last terms, when multiplied together, have to be positive 6. Okay, they have to be positive 6. But what else we can determine from this is if this is positive, that means the sign of these 2 terms, guys and ladies, you're getting to my pushing point. These 2 things have to have the same sign, because a positive times a positive gives a positive, or a negative times a negative gives a positive. So the way we determine what sign they are is we look at the b term. The b term is negative, so both of these are going to be negative. So we need 2 numbers that multiply together to be 6. So we've got 1 and 6 or 2 and 3. But what do they have to add up to? 5. So it's going to be 2 and 3. Does it matter what direction I put them in? No. Because the signs are the same. Remember who gives you the assignment at the end of the day. The other class went through this today too, for some reason. Because the signs are the same, doesn't matter. If you put x minus 3 and x minus 2, doesn't matter. Now, that's one method to use to do this. And if your a value is 1, this is a pretty good way to do it. And you guys are pretty good with your math facts anyway. Another way to do these, and the way we do the most about the high school teachers use what's called the X method to do these. And this really works well when your a value isn't 1. On the top of your x, you're going to take the a times the c value. So remember, your a value is the value out in front of the x squared. Your b value is there, and that's our c value. So if I take a times c, that's going to be 6. Your b value is going to go in the bottom down there. In this case, it's -5. Now we're going to fill this middle portion here and here with two numbers that multiply together to be positive 6 and add together to be -5. Now this is negative and this is positive, so since this is positive, our b value, or a times c is positive, both of these have to be the same sign. And because the b value is negative, they're both going to be negative. So we've got a negative here, and we've got a negative here. So, and we've already said it's 2 and 3. And again, we already knew the answer to this, but it's another way to do these. And when the a value is 1, probably not necessary. But when your a value isn't 1, then this way is a lot more efficient. So if we have 10x squared plus 2x minus 36, first step still has to be to take out a GCF. GCF for this is 2. So that gives us 5x squared plus x minus 18. Now my a value is 5, so I'm going to do the x method. I'm going to do it on the side over here. So the top is a times c. So my a value is 5. My c value is -18. So multiply them together, you get -90. And that -90 tells me a lot right now. It means that in these middle terms, because that's negative, and the middle terms have to be multiplied together, that means one has to be negative and one has to be positive. So we've got one that's a negative, we've got one that's a positive. The b value goes in the bottom. My b value in this case is 1. And make sure you use our factored one, don't use the top one. So now I need two numbers that multiply together to be -90 that add up to 1. 10 and 9. So 10 and 9 are the numbers that I'm going to use. Which one's positive? The 10 has to be positive. The 9 has to be negative. -9 times 10 is -90. -9 plus 10 is 1. Okay, so if we look at it just how we did the last one, this becomes 2 times x minus 9 times x plus 10. Does that work? What's x times x? It needs to be 5x squared. So here's where a little bit of a mathematical trick comes into play. We have to have 5x squared. So what we're going to do is we're going to take both of these values and we're going to divide them by 5. Notice how this first one doesn't reduce. You reduce the fraction if you can. If you can't reduce the fraction, the denominator goes out in front of your variable x, and then whatever operation it is your numerator. So our first one becomes 5x minus 9. And if you look at the second one, 10 divided by 5 is 2. So we just reduce the fraction. This is the factored form of that. The X method, I think, works a lot better for this. It's, again, wouldn't be bad because you know one of these has to be 5 because of that 5x squared. But if that's something like a 10 or a 20 or a 16, you can start to get a lot of things in there that make it much more complicated if you're trying to guess and check. And there's a lot of things that you'd have to go through to guess and check those. And again, our whole goal today is to get to this piece of it. Eventually, we're going to set this equal to 0 and solve. But that's not today. Okay? Give you a couple to try. Go ahead and factor that one completely. What's first? Common factor? 4. What goes on the top? Negative 10 on the bottom. 3. The top is negative, so that means one has to be negative and one has to be positive. 2 and 5, which one's positive? 5 is positive, 2 is negative. So 4 times x minus 2 times x plus 5. Should be your solution. Questions with that one? Go. Factor that one completely. Common factor. 2. 5x squared minus 19x minus 30. What goes on the top? Negative 150. On the bottom, negative 19. Now it's negative on the top, so that means one's negative and one's positive. So they have to multiply together to be negative 150, add together to be negative 19. What is it? 25 and 6. Which one's negative? 25 has to be negative. 6 has to be positive. So if we do it how we did the last one, it's 2 times x minus 25 times x plus 6. Of course, that doesn't work. So we have to divide by 5. So that's 2 times x minus 5. 5x plus 6. That should be your completely factored one. Now, when I do these, and you'll get good enough with these too eventually, I don't write that part right there. I just go over here and divide that by my a value. This is going to do a couple things. One, you can just reduce that to 5, negative 5, and then you've got your 5x plus 6. You can save a thing for writing, but also eventually we're going to start to find the zeros. And what you're going to find out right here, these are going to be essentially the opposite of what your zeros are. Okay, so that's kind of a prelude to where we are going to go in a second. Okay? Not a second, a day or two. Factoring, that's a quick lesson, something that generally probably takes 3 or 4 days. We did it in like 30 minutes. Are we good with these types of factoring? Remember how to do it all now? All right. Assignment for tonight is inside of Schoology.